this is your very last video of the semester. So it seems appropriate that I stay with our current audience to math, and you can do anything. So keep going. This is it. This is the last one. This will be on your final, and it will be on your quiz. So just be prepared for that. Okay. So we're going to look at trigonometric equations today. But first, I wanted to go back and just mention a few things that I'm just touching upon. This is not on your final, but I do want you, and it's not on your quiz, but I do want you to see it. At some point, this is something that you should be looking at on your own, okay? So the first thing is we talked about right triangle trigonometry, and I touched upon this idea that you can you could figure out these missing sides and these missing angles for triangles that aren't right triangles. So if we take an example, okay, just any old triangle, and we say that this side is 12, this is 32 degrees, and this side is 15. And we want to find this side. Now we cannot use the Pythagorean theorem because the Pythagorean theorem only applies to right triangles. So we have to use something else, okay? And in this particular case, we can use something called the Law of Cosines. So the Law of Cosines uses three sides and an angle, okay? And it says that c squared is equal to a squared plus b squared minus 2ab times the cosine of c, okay? If you notice, this side is opposite this angle. So if you remember, we talked about the way that we labeled triangles, and we said that we label triangles so that the angles are uppercase letters and the sides are lowercase letters, and the lowercase letter is the side that is opposite the angle with the same uppercase letter. So for example, this would be side C because this is what we're looking for, and this would be angle C. So in order to find side C, we have to know the angle that's opposite it, because that's what we use in our formula, okay? So in order to find this side, we have to know the angle that's opposite. Okay, you can see that in the formula here. And the way that you would prove this formula, which we're not going to take the time to do, but if you ever want to know, I can, obviously just email me. We also need to know the other two sides, right? The other two sides are in here. So this is what you would use if you have an arrangement like this, where you have two sides, and we call this the included angle. And it's just a plug and chug, okay? It's just c squared is going to equal 12 squared plus 15 squared. It doesn't matter which side is A and which side is B. It makes no difference here. So we have 15 squared, and then minus 2 times 12 times 15 times the cosine of 32 degrees. Okay, so it's simply plug and chug, but you have to, in terms of what you know, it's got to be in this arrangement where you have two sides and you have the included angle, and then the opposite side is the one that you're trying to find. So that would be the law of cosines. Now, we can also have, right, sometimes this is not the arrangement that you're given as what you know. So sometimes we're given a triangle where we know different things. So let's say, for example, we know this side, and we say that this side is 8. We know this angle. This angle is, let's say, 18 degrees. This is the angle that we're looking for. So this time, let's say that we're looking for an angle. I'm going to make this triangle a little bit bigger because you can't really see it. So this is 8. This is theta. This is 18 degrees, not drawn to scale. And this is what we're trying to find. So we know a pair that's opposite. Sorry, we're trying to find the angle. This is, let's make this 6. Okay, so we know a pair where we know the side and the angle opposite it. And then we have another pair where you have one unknown, okay? So here we know the side, we're looking for the angle. If we had known this side, then you would be using the law of cosines, okay? But here, we use something called the law of sines. So in the law of cosines, you can know all 3 sides and be looking for an angle. Or you can know 2 sides and the angle included, okay, the included angle, which is the angle between those 2 sides. For the law of sines, it's different information that you would know. People write this differently. I tend to write it as sine A over A equals sine B over B, which is equal to sine C over C. So you're only using 2 of these at any given time. So depending on what you're looking for and how you label your triangle, you might be using sine A over A equals sine B over B. Or you could be using sine B over B equals sine C over C. Or you could be using sine A over A equals sine C over C. And sometimes you'll see it, some people will write it where the sides of the triangle are the numerators and then the sines of the angles are the denominators. It doesn't matter, okay? Ultimately, it doesn't make a difference as long as you're consistent. Let's label this triangle. And again, it doesn't matter the way that you label it as long as if you have an A here to label the angle, then the side opposite is the lowercase a. So if we say that this is A, then this side has to be side A. If this is side B, if that's angle B, if this is angle B, then this has to be side B. And if this is angle C, then this is side C. So we know we're looking for angle A, we know side A. And we know side C and angle C. So we can use law of sines. Notice we would not be able to use law of cosines, because law of cosines, we either need to know all 3 sides or we need to know 2 sides, and the angle that we know has to be the angle in between, okay? Here, or we can know, right, I gave you all of the possibilities already, I forgot. For the law of sines, you have to have pairs, right? And you're going to know if you're using the wrong one because you won't be able to plug into this formula, okay? And again, we can derive it. You derive it using right triangle trigonometry because every triangle could be redrawn as right triangles. So like for instance, we could cut this cut this with a perpendicular line. So this would be a plug and chug also, right? So it would be sine of theta over 6 is equal to sine of 18 degrees over 8. And we could just, cross multiply, and a cross multiplication is multiplying everything by 8 and then multiplying everything by 6 on both sides of the equation. So we could cross multiply and solve for sine of theta. Remember, when you're solving for an angle, you are going to have to take the inverse of sine of theta. You're going to have to take the inverse of both sides at some point. Okay, but this is the way that you would solve for missing sides or missing angles in a triangle that is not a right triangle. This is not going to be on your quiz. It is not going to be on your final, but I do want you to become familiar with it because you will be using it in calculus. Okay. The second thing that I wanted to show you is that there are other identities. Okay. So the other identities that we have are like half angle identities. What does this mean? It means we can express or find the sine of 30 degrees using 60 degrees. Okay, or if we use radians, the sine of pi over 6 using what we know about pi over 3. We have double angle identities. We have sum and difference identities where we can find the sine or cosine of an angle using two angles that we already know. So for example, if we want to find 60 degrees, we might use 30 plus 30. If we want to find let's say 75 degrees, we can use 45 and 30 degrees. So we can use sums and differences of angles that we know. And when I say angles that we know, what I mean is that angles that we know the exact values of. So these would be the other identities. Okay, so we have sum and difference identities. These are the ones that we talked about. Okay, our cofunction identities is the sine of an angle is equal to the cosine of its complement. These are the ones that we sort of talked about already, but these are the other identities that you could be using. Okay, so the sine of 75 degrees, you can use the sine of 15, the sine of 30 and the cosine of 45 plus the cosine of 30 times the sine of 45. So you can use these. We're not spending time on this, but before you go into calculus, okay, you must become familiar with these. You should be looking at them, plugging in, seeing how they work, becoming more familiar with these identities so that when you go into calculus, you are more familiar with it. You can plug in values. You can find exact values. So these are all plug and chug. We can prove them. We can derive them. I'm just not taking the time. The semester ended. But you can, these are what the identities look like. And I will post these with the trigonometry lectures so that you have them. But again, They're not going to be on your final or on your quiz, but this is something that you should concentrate on before the next semester. Okay? Okay. So, equations, trigonometric equations. The nice thing about trigonometric equations is they're very much like everything that we've done so far. We've solved equations. The way that you solve equations is no different when they're trigonometric, okay? What changes is really how you express your answer, because your answer is in angles. Now, I'm going to go back to that exact value chart. I'm going to put it in here again, even though we've written it in our notes twice. I'm going to review it with you one more time. And what I want you to concentrate on is the angles and radians, because we're going to be working with both, but you really have to become familiar with these radians, okay? And a lot of the problems that we're going to do are going to be using the radians instead of the degrees. Now, I want you to know, if you're very uncomfortable, you can always express your angle in degrees and then convert it to radians, but that's extremely inefficient, okay? So our exact value chart, we have your 0 degrees, your 30 degrees, 45, 60, and 90. Now, if you're using the pattern to create this exact value chart, you have to realize that these angles have to be in increasing order, and you have to remember that there are 5 of them, okay? So, because if you forget that there are 5, then your pattern is going to fall apart. Now, 0 degrees easily is 0 radians. That's easy to remember. And then these other angles, remember that 180 degrees is pi. So what's 30 degrees? Well, that's pi over 6, right? 180 over 6 is 30. 180 over 4 is 45. 180 over 60, 180 over 3 is 60. And notice 180 divided by 60 is 3, right? 180 divided by 60 gives us our 3, so it gives us our denominator. And then 180 over 90 is 180. It gives us pi over 2. 180 over 90 is 2. Or 180 over 2 is 90. Okay, so that gives you your angles and radians. Become very familiar with this. Okay, make flashcards if you have to, but you should be very familiar with these angles. Okay, and like I said, most trigonometric formulas, most formulas that come with like area of a circle, they're much simpler. Okay, if we take area of a part of a circle, those formulas are much, much simpler if you're working in radians versus degrees. Okay, then in this chart, we're looking at sine, cosine, and tangent. Remember, if you know the sine of an angle, you also know the cosecant because it's the reciprocal. If you know the cosine, you also know the secant. And if you know the tangent, you also know the cotangent, okay? Because those are all just reciprocals. The sine of 0, remember that can come from the unit circle. You can also remember this using those triangles that I showed you in a previous lecture. But if you remember all of these, I'll put it in a different color so that it's really clear what your answers are. All of your denominators are 2. I'm leaving a little bit of room so that we can write the simplified version as well. And remember, if you know all of your sines, then you know all of your cosines, because the sine of an angle is equal to the cosine of its complement. So you don't have to remember this whole table. If you know your sines and your cosines, you don't need to know your tangents because tangent is sine over cosine. So you don't have to remember the whole table. If you remember just the sines of every angle, then you know you can figure out everything else. Okay. So our pattern is for sine, it's 0, 1, 2, 3, 4, and then you take the square roots. Okay. For cosine, it's the opposite. It's 4, 3, 2, 1, 0. And then for tangent, again, we have all fractions here. They're ratios, right, of the sides of a right triangle, so it makes sense that we have fractions. And it's sine over cosine. So those 2's in the denominator cancel out. And here we have 0, 1, 2, 3, 4, all square roots. And then we have 4, 3, 2, 1, 0, all square roots. Okay. If we simplify as much as possible, again, I'll use a different color. This is just going to be 0. Square root of 0 is 0, and 0 over anything is 0. This is going to be 1/2. Square root of 2 over 2 cannot be simplified, and neither can square root of 3 over 2. But square root of 4 over 2, square root of 4 is 2, so 2 over 2 is 1. And this 0 and 1 makes sense, right? At 0 degrees or 0 radians on the unit circle, the y value is 0. At 90 degrees or pi over 2 on the unit circle, the y value is 1. So this makes sense, okay? And then we're looking at the x values. The x value at 0 degrees and 0 radians is 1, okay? And the x value in 90 degrees or pi over 2 is 0. The sine of the angle is equal to the cosine of its complement. Square root of 3 over 2 can't be simplified. Neither can square root of 2 over 2, but square root of 1 over 2 is 1/2. Square root of 0 over square root of 4 is 0. Square root of 0 is 0. Anything over 0 is 0 over anything is 0. This is 1 over square root of 3, but when you rationalize your denominator, it becomes square root of 3 over 3. Square root of 2 over square root of 2 is 1. Anything over itself is 1. Square root of 3 over square root of 1 is just square root of 3. Square root of 1 is 1, so square root of 3 over 1 is square root of 3. And square root of 4 over square root of 0, well, this is undefined because you can't divide by 0. Okay, so you should be able to put it in its simplest form. You don't have to start off with it in its simplest form. So if you're remembering the sine of 30 is square root of 1 over 2, that's fine. Then put it in your simplest form, okay? So how you remember it, it doesn't matter. Now, obviously, on your final, it's more like a take-home, so you don't have to memorize this. But I will warn you, you go into a calculus class and you don't know the sine of 30 off the top of your head, it's going to be a problem, okay? Okay, so let's start solving equations and seeing how we use this, okay? Now remember, 0, 30, 45, 60, and 90 are all reference angles, okay? So these are all reference angles, and we're going to be using them as reference angle. And the way that we're going to learn to solve equations is we're just going to solve a bunch of them. So let's take the sine of x plus the square root of 2 is equal to negative sine of x. Okay, this is going to be our first equation to solve. Okay, and I want you to remember that, and we talked about this a lot, there's not only one angle where the sine is 1/2, right? 30 degrees, the sine is 1/2, but there are other angles that have a sine of 1/2. Specifically, the sine of 150 degrees is 1/2 because the reference angle for 150 degrees is 1/2. So we're going to find all of the angles for which we solve the equation, okay, for which the equation holds true. So how do we solve this? Well, the idea is that we solve for x, okay? We are solving for our variable. And I think in all of these examples, we're going to use x. So I'm going to say solve for the unknown, but in these cases, okay, so it might be x. It might be theta, or it might be something else altogether, but it's whatever your unknown is. Okay. So how do we do this? We do it in exactly the same way that we solve for anything else. We isolate our trig function, okay? So how do we isolate the trig function? We are going to add the sine of x to both sides, okay? Or subtract the sine of x from both sides. We want our variables on one side, we want our trig function on one side, and we want our numerical values, our constants, on the other. So just like we would isolate the absolute value, we would isolate the square root, we would isolate the exponential function, we isolate the trig function. So the fastest way to do this in this case is subtract the sine of x from both sides. Okay, now on this side it's going to cancel. Sine of x minus sine of x is 0. But be careful. Here we get square root of 2 is equal to negative 2 sine x. Okay, negative 1 minus 1 is negative 2. Be careful there. Okay, so now what? Well, again, we still isolate. So now we divide both sides by negative 2. Okay, the negative 2 will cancel here. And what are we left with? We are left with sine of x is equal to negative square root of 2 over 2. Okay, we've isolated the trig function. Now what? Well, now we have to find x. We found the sine of x. We found that the sine of x is equal to negative root 2 over 2. But there are two answers here, okay? Because we have two angles where we have negative root 2 over 2. Two angles that have the same sign, okay? Remember, the unit circle is symmetrical. So we have our circle. Remember, at any given point, you have two points that have the same y value. you have 2 points with the same x value. Okay, so 2 points with the same y value, the same sign. So we have to figure out what both of those points are. So square root of 2 over 2, you have to figure out what the reference angle is, because that's going to tell you what the sine is. We know that the sine of any angle is the same as the sine of its reference angle. It might be positive or negative, okay, but it's the same value. No apostrophe. So depending on what quadrant we are in, it might be negative, right? So here, what you're going to do is the next thing that you're going to do is you're going to identify what the reference angle is. Okay, so sometimes I'm going to tell you do it in degrees, and sometimes I'm going to tell you to do it in radians. So this one we're going to do in radians, and typically in the next problems, I'm going to tell you, okay? So in this one, we're going to do in radians. And we're going to get even more specific in a few minutes, okay, where we give you the domain. Okay, this is where your exact value chart becomes important, because what you're doing is you're saying, okay, which angle has a sine that's equal to the square root of 2 over 2? Don't worry about the negative yet, okay? Don't worry about the negative. Well, let's actually... Before we identify, I realized that it makes more sense to do it the other way. Instead of identifying the reference angle first, identify which quadrant you're in. You can do this in either order, but it kind of makes sense to do this first. So identify the quadrant you're in. What do we mean? The sign is negative. In which quadrants is the sign negative? So the sign is negative in quadrants 3 and quadrants 4. So based on whether your trig function is positive or negative, so in quadrant 3 and quadrant 4, this is where sine is negative. Now you're going to identify your reference angle. Okay, so what's our reference angle here? Our reference angle, well, we're looking for an angle where the sine is square root of 2 over 2. That's pi over 4. So that's our reference angle. Okay, so how do we find the angle in quadrant 3? Well, in quadrant 3, this is a little bit different, right? In order to find the reference angle, if we have an angle in quadrant 3, we would do the angle minus 180 degrees, but that's not the case here, okay? What we're doing is we're trying to say, okay, we start from here. We know that this is pi over 4. So how do we find the angle that goes from here to here? Well, we know that this piece is pi over 4, and what do? We already went half a circle, so we have to add in pi over pi. So this says x is equal to pi plus pi over 4. And this one says, okay, well, we want to go all the way around. Well, it's 2 pi minus pi over 4. And we're going to do a lot of these. Okay, now I'm going to give you the answer here, but we're going to discuss it on the next page. So pi plus pi over 4 is 5 pi over 4. And we'll get to that. I kind of ran out of room here. This is 7 pi over 4. But let's talk about that, okay? So our answers are 5 pi over 4 and 7 pi over 4. These are our answers. Okay, so let's talk about this a little bit more. We have a reference angle here where this is pi over 4. Now we need to know, not the reference angle, we need to know what the actual angle is. We need to know this. So the question is, how do we find this? So this angle is pi over 4, but we need to start from here. So how do we do that? Well, from here all the way around, this is pi over here, right? This is pi. So what are we doing? We're walking a distance of pi, and then we're going an additional pi over 4. So this angle in quadrant 3 we're doing pi plus pi over 4, or pi plus our angle, whatever our reference angle is, it's pi plus our reference angle. Okay, so pi plus pi over 4, we got 5 pi over 4. So how did we do that? Well, we needed a common denominator. This is like pi over 1. So if we needed a common denominator, we needed the denominator of the first fraction to be 4. So we multiplied by 4 over 4, which gave us 4 pi over 4 plus pi over 4. And that's how we got the 5 pi over 4 on the other side. Okay, let's look at quadrant 4. So in quadrant 4, again, we had a reference angle of pi over 4. But we don't want the reference angle. What we want here is this angle. We want the opposite, okay? So if we want the opposite, what's in pink, what we're really doing is we're saying, let's go around the whole circle, but we're going to go pi over 4 less than the whole circle. So we're going to go in quadrant 4, we're going to go 2 pi minus pi over 4. What that'll do is it'll say, okay, let's delete this. Let's erase this. And that's going to give us this angle here. Okay. Now we said that that gives us 7 pi over 4. So how does that happen? It happens in the same way that it did over here. Okay. 2 pi is really 2 pi over 1. So we need a common denominator. Okay. What that does is it gives us 8 pi over 4 minus pi over 4. Well, what's 8 pi minus pi? 8 pi minus pi is just 7 pi. So that's how we got those two answers. And note that in quadrant 4, what we're doing is we're doing 2 pi minus our reference angle. Okay, and that's how we would do it every time that we're trying to find an angle in quadrant 3, or any time that we're trying to find an angle in quadrant 4. In quadrant 3, we would do pi plus our reference angle because we're going pi and then plus the extra piece. And in quadrant 4, we would go 2 pi and then subtract that extra piece, subtract that reference angle. So we're not going quite all the way around the circle. We're going all the way around the circle minus the reference angle. Okay, and what does that mean for the other two? So if our angles if our angles were in quadrant 1 or quadrant 2, let's just take a look at that. So quadrant 1, that's so crooked. That's better. Okay. If our angle were in quadrant 1, here's our angle, then it's easy, right? In quadrant 1, it's just our reference angle. But if our angle were in quadrant 2, here's our reference angle. Okay, if that's our reference angle, we're not looking for that, right? We're looking for the angle coming from here. And if we're looking for the angle coming from there, well, we're not quite going pi, right? We're going pi minus our reference angle. We're going less than pi. So keep in mind, how do you remember which is which? Well, first of all, draw a diagram. That will help, okay? Second, we're only using pi or 2 pi, okay? If it's not just the reference angle like it is in quadrant 1, we only use pi or 2 pi. Notice we never use our y-axis, ever. Same thing for finding the reference angle. This is saying find the angle given the reference angle, okay? So for this, it's either going to be pi plus if you're in quadrant 3 because you're going further than pi, or pi minus if you're in quadrant 2 because you're not going as far as pi. You're going less than pi. And then for quadrant 4, you're not going as far as 2 pi. You're going less than 2 pi, so it's 2 pi minus. Okay? And this is just to help you find the angles. Once you find the reference angle, then you can find the actual angle. So that would be your step 4. You're finding your actual answer. Okay, and I'm going to put in here, pay attention to the domain. Right now, in this problem, don't worry about it. In future problems, we will. Okay, pay attention to the domain. So in this one, I'm going to say, don't worry about this for this problem though. The domain, we're going to say is in the interval 0 to 2 pi. Okay. So in other words, we're just going around the circle once. We're not going around the circle an infinite number of times. Okay. Let's do another problem. Let's say, for example, we do sine of x. So we're going to find x in the interval 0 to 2 pi. So we're going to do radians again. Okay. If it said 0 to 360, the only thing that would change is that instead of seeing pi here, you would do 180. Okay. And instead of using 2 pi, you would use 360. Instead of using pi here, you would use 180. And instead of saying that your answer is pi over 4 as your reference angle, you would say that your reference angle is 45 degrees. Okay, so you would just be using degrees instead of radians. Okay, find x in the interval 0 to 2 pi. So this is telling you that your answer is in radians. For similar problem, sine of x minus square root of 2 equals negative sine x. Okay, very similar problem. So once again, same process, okay? We're going to isolate our trig function. So this part is straightforward. This part is the stuff that you've done over and over again. It's that very last part where you're finding your x after you've isolated the trig function. That's the new part, okay? So we can subtract sine x from both sides. Okay, this is not the only way to solve, right? Some of you I know would add sine x to both sides. Just be careful however you do it, okay? But I'm just going to do it this way where we get, where I move the sine x so that it's on one side, the constant so that it's on the other side. So if you do it differently, that's fine. I know ultimately you get the same answer. So what do we get here? We get negative root 2 is equal to negative 2 sine x. Now we're dividing both sides by negative 2. And the difference is that your answer, your sine of x here, is now a positive number. Okay, so at this point, we've isolated our trig function. Okay, so the next thing that we're going to do is we're going to identify which quadrants are we in. So in the last problem, we kind of broke it all up, which might have, you might have lost your train of thought somewhere in there. Here, we're just going through the problem step by step, so it'll be easier for you to follow. Okay, so our first step was we isolated the trig function. Our next step is to identify the quadrants. So what are we doing? In this case, we're looking for quadrants where sine is positive. How do we know that sine is positive? Well, we look at our answer, and our answer tells us sine is positive. So which quadrants are we in? Well, sine is positive in quadrants 1 and 2. That's where our y values are positive. So we're going to have answers in each of these quadrants. What's our next step? Our next step is to figure out our reference angle. Well, that's where we go back to our exact value chart. And you should know in your exact value chart where you are, okay? You should not have to go back and look at it. So we're going to identify our reference angle. Now we are in radians because we look at 0, 2 pi. We look at the interval and it tells us that we're in radians, okay? Because we have 2 pi. We're going from 0 to 2 pi, not 0 to 360, okay? So we're saying what angle has a sine of square root of 2 over 2? Well, that's pi over 4. Okay, that's our reference angle. So what angle has a reference angle of pi over 4 in quadrant 1? Well, quadrant 1, the reference angle is the angle itself, right? Reference angle is the angle itself. So in quadrant 1, x is equal to pi over 4. What's the angle in quadrant 2? Well, in quadrant 2, again, your reference angle is this angle here, okay? So we want to know, well, what's this angle in pink? What's the angle if we start at the positive x-axis and then go to our terminal side? Well, that's pi minus pi over 4. And if we multiply by 4 over 4, this is the same thing as 4 pi over 4 minus pi over 4. Or 3 pi over 4. So these are our answers here. Okay, and once again, the 0 to 2 pi, the 2 pi is what tells us answer should be in radians. Okay, so let's talk about this interval for a second, okay? So what the interval says is that we're going around the circle once, okay? Now, there's a bracket before the 0 because you're including 0 radians. Now you're not including 2 pi radians, and the reason why you're not including 2 pi radians is because 0 and 2 pi give you the same answer, right? You're right back where you were when you're at 2 pi. You don't want to repeat, okay? So there's a parentheses here because, because 0 and 2 pi are the same, and you don't want any repetition, okay? So the first thing is 0 to 2 pi says your answer should be in radians. And you're only looking at one rotation around the circle. Now the same thing is true if you went from 0 to 360. Okay. This says your answer should be in degrees. And you are looking at one rotation around the circle. Now, if it doesn't give you an interval, okay, if you have no interval, then things change again, okay? And the reason that things change is because you're saying, well, I want every angle that has this reference angle and a positive sign, I want it going around the circle an infinite number of times, okay? Which means that as we go around the circle here, okay, let me go to the next page. What we're doing is we're saying, if this is your angle, okay, if this is theta, you don't just want this angle. You also want this angle. So you also want the angle if you go around the circle again. Okay? You also want the angle if you were to keep going. So you want that angle too. These are all the same angle. Okay? So you want that angle too. You want the angle if you were to go around a third time. If you were to go around a fourth time, a fifth time, an infinite number of times. Okay, so in other words, if x equals pi over 4, you also want x equals pi over 4 plus 2 pi. And x equals pi over 4 plus 4 pi. Okay, or pi over 4 plus 2 pi a second time. And you want x equals pi over 4 plus 2 pi a third time. And x equals pi over 4 plus 2 pi a fourth time. Okay, so what do we mean by 2 pi times 2? 2 pi times 3, 2 pi times 4? Just as an example, this is 3 rotations around the circle, a fourth rotation around the circle. You want a 5th rotation, a 6th rotation, a 7th rotation, okay? You want all n rotations. So your answer would be, instead of x equals pi over 4, you would have x equals pi over 4 plus 2 pi n times for all of the rotations that you go around the circle, okay? This n is n rotations around the circle. Okay, so that would be your answer. So if there is no interval, then our answer here, instead of just being pi over 4, if we hadn't specified an interval, you would have written pi over 4 plus 2 pi times n. And you would have written 3 pi over 4 plus 2 pi times n. Okay, because you're saying it's pi over 4, but it's also pi over 4 plus 2 pi, plus 2 pi again, plus 2 pi again, plus 2 pi again, n times, okay? And 3 pi over 4, plus 2 pi again, plus 2 pi again, plus 2 pi again. So if there is no interval, then you add 2 pi over n, okay? And I'll also make a note here that it has a parentheses at the end. Because 0 equals 2 pi. Or 0 equals 360 degrees. Okay. Sorry, it didn't come out. So let's get to more solving of equations. And we're going to use intervals and no intervals. And as soon as you start doing it, you're going to get accustomed to it. Okay. So let's say that we have so this is our third example. Let's do this one without intervals, okay? And we're going to do everything in radians, okay? Everything is going to be in radians, just because I want you to get really accustomed to it, and you're already accustomed to degrees. So this one, 3 tangent squared x minus 1 equals 0. So if you notice, I'm not saying in the interval. That means that you're going to have to do this addition, okay? So once again, all we do is isolate. So we're going to add 1 to both sides. Okay. So we get 3 tangent squared to x is equal to 1. Now we divide both sides by 3. All of this should be familiar to you, okay? So we get tangent squared to x is equal to 1/3. We need to isolate tangents. We have to take the square root. Now, when we take the square root, remember, you need a plus or minus every time you take the square root. Okay, don't forget the plus or minus. So what does this give us? Tangent of x is equal to plus or minus 1 over the square root of 3. Okay, so square root of 1 is 1. Well, if we go to our, this is the same thing as square root of 3 over 3. Right? If we rationalize our denominator. So, first of all, what quadrants? I'm going to bring this up here. Okay. So we are in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We're in every quadrant because of this plus or minus. Tangent could be positive or negative. We're in every quadrant. Now we need the reference angle. Well, we're going to go to our exact value chart and we're going to find our reference angle. Square root of 3 over 3. You should know this, okay? I want to show you the exact value chart again because I want you to become familiar with how to use it. So our tangent is square root of 3 over 3, so we're looking inside the chart now, okay? When we're looking for tangent inverse, you're looking inside the chart when you're looking for the angles. So square root of 3 over 3, that's pi over 6. So our reference angle is pi over 6. Okay, so in quadrant 1, don't forget to write x equals. Okay, in quadrant 1, it's pi over 6, and then there is no interval, so we're going to write 2 pi n. In quadrant 2, if you remember, you take pi and you subtract pi over 6. So that would give us 5 pi over 6. Practice with your fractions. And then we'll do plus 2 pi over n. Quadrant 3, that's pi plus pi over 6. Or 7 pi over 6. Plus 2 pi n. And then x equals 2 pi minus pi over 6. And that gives us 11 pi over 6. plus 2 pi n. Okay, so a couple of things here. First thing is, remember that the way that I'm getting 5 pi over 6 is we're multiplying top and bottom by 6 over 6. So we get 6 pi over 6. 6 pi minus pi is 5 pi. This one, it's 6 pi plus pi over 6. 6 pi plus pi is 7 pi. And this one, when we multiply 6 by 2, we get 12 pi over 6. So 12 pi minus pi is 11 pi. Okay? Now here's the thing though. So this is kind of special because we're in all 4 quadrants. And when we're in all 4 quadrants, that makes a difference in our answers. So let's take a look at being in all 4 quadrants. So this is pi over 6. And then we're going to take a look at this. This is also pi over 6, right? Same reference angle. Well, that means that we could also save our, this is quadrant 1, and this is quadrant 3. Well, here's the nice part of this. Okay. The nice part of this is that we don't actually have to identify both of these angles. Because if I can identify this angle here, if I add pi to that angle, then it brings me to the angle in quadrant 3. And if I add pi again, so this is plus pi. If I add pi again, it brings me back to quadrant 1. If I add pi again, it brings me back to quadrant 3. And if I add pi again, it brings me back to quadrant 1. So it turns out that we can actually write this in a different way to save ourselves from having to write all 4 quadrants. We could instead say, well, in quadrant 1 and quadrant 3, we could say x equals pi over 6 plus pi times n. That'll give us the angles in quadrant 1 and quadrant 3. So instead of writing plus 2 pi n, I could take care of the angle in quadrant 3 also by just writing pi plus pi n. Because instead of adding 2 pi and just getting the angles in quadrant 1, I can add pi and then I'll get us the angles in quadrant 2. In quadrant 3. And the same thing is true for quadrant 2 and quadrant 4. Once I find the angle in quadrant 2, I can also find the angle in quadrant 4 in the same way. This is 5 pi over 6 plus pi times n. Okay, and that saves us. We don't have to do the quadrant 3 and quadrant 4 separately. And that's always going to be true. If we have angles in all 4 quadrants, we can put quadrant 1 and quadrant 3 together, and we could put quadrant 2 and quadrant 4 together. Okay. Let's take another example. You don't have to do this, but it does make it much more efficient. Okay? Much more efficient. So let's do another example. Let's do 4 sine squared x minus 3 is equal to 0. And once again, we're not going to give you an interval, but we will say in radians. Everything is in radians. Okay. So once again, we add 3 to both sides. Okay, we're just isolating our trig function. That's what this is about. So we have 4 sine squared x. And sometimes you'll see x, sometimes you'll see theta. Just be consistent that in your final answer, if it's theta, then in your final answer you're going to write theta equals. We divide both sides by 4. Sine squared x equals 3 over 4. This is sine squared. We have to get rid of the square, so we take square root. And it's plus or minus. Don't forget your plus or minus. Okay. So what do we have? We have sine of x is equal to plus or minus square root of 3 over 4. This is the same thing as plus or minus square root of 3 over 2. Okay, the square root can be distributed. So you have square root of 3 over square root of 4. Square root of 4 is 2. So what quadrants are we working in? We're working in quadrants 1, 2, 3, 4. Okay, because it's plus or minus. When you see a plus or minus, it's all 4 quadrants. And remember, we compare quadrant 1 and 3. Because we're just going to do plus pi n. And we can pair quadrants 2 and 4. We can only pair, so obviously if it weren't plus or minus, there's no quadrants to pair. So now we need our reference angle. Okay, so we're thinking of, well, the sine of what angle is square root of 3 over 2? Okay, and if you're familiar, which you should be, it's pi over 3. So our reference angle is pi over 3. Okay, so we really only have to worry about quadrant 1. We don't have to worry about quadrant 3. We only care about quadrant 1. So in quadrant 1, our x is just pi over 3. But now we have to take care of all of these angles that have this, okay? All of these angles. Going around the circle an infinite number of times. So in order to take care of quadrant 3 also, instead of adding 2 pi n, we're only going to add pi n. Again, this only works when you have a plus or minus, right? If this had just been sine is positive, quadrant 3 wouldn't be here because quadrant 3 has a negative sign. Okay, and we only have to worry about quadrant 2 for the same reason. So quadrant 2, it's not pi over 3, right? It's pi minus pi over 3. Well, that gives us 3 pi over 3 minus pi over 3. Or 2 pi over 3. So what's our answer? 2 pi over 3 plus pi times n. Because we have 2 quadrants to take care of. It's pi times n instead of 2 pi because we also have to get the angle in quadrant 4. So this is our answer. Okay, it's pi n because we're working for angles in 2 quadrants. Okay, quadrant 1 and quadrant 3 and quadrant 2 and quadrant 4. Okay, let's take another one. And this time, okay, let's take another one. And again, for this one, I'm not going to give you an interval. I will give you an interval again, but not yet. Let's take cotangent of x cosine squared x is equal to 2 cotangent of x. Okay, so this is really different, right? How do we do this? Okay, so when you see two different trig functions like this, you want to be careful. You never want to cancel out a trig function. So you never want to get rid of a trig function. And this is really important because by getting rid of a trig function, you lose an answer. So we talked about this in the last lecture. Okay, we talked about this in the last lecture. We said when you verify identities, you only work with one side at a time. This is the reason, okay? If we were to take both sides and cancel out cotangent of x by dividing both sides by cotangent, we actually lose answers to our equation. So we never want to do that, okay? So now the question is, if we don't do that, then how in the world do we solve this? Set it equal to 0. So when you're not sure what to do, this is your go-to. Okay, when you're not sure what to do, that's what you do. So how does that affect this? We subtract 2 cotangent x from both sides. Okay, and what does this give us? Cotangent of x cosine squared x minus 2 cotangent of x is equal to 0. And now we're just saying, okay, how do we solve this? So you certainly can add 2 cotangent of x to both sides because then you just undo what you did. But if you notice, cotangent of x exists in both terms. So we can factor it out, okay? So one of the things that you should always be looking for is, can I factor? Okay, and we see 2 different trig functions. That should be something that you think about. Now you can also think about Pythagorean identities, okay, but which is perfectly fine. If you can find a Pythagorean identity to make things work, that's perfectly fine. You can do that. But we don't have a Pythagorean, or at least not a clear Pythagorean identity here. So our option is pull out cotangent of x, factor. Okay, cotangent of x is in both terms. So we pull it out. And what are we left with? Cosine squared x minus 2. And now it doesn't matter that we have 2 different trig functions because we can use the 0 property. We can set each trig function equal to 0. So either cotangent of x equals 0, or cosine squared x equals 0, or cosine squared x minus 2 is equal to 0. Okay, now we solve each equation. This is the 0 property. Okay. Okay. So we need to figure out where cotangent of x is equal to 0. So we're going to start with that one. And I'm going to put these in red as your two separate equations. Okay, we need to figure out where the cotangent of x equals 0. But we don't know cotangent of x, right? We only know sine, cosine, and tangent. But that's okay, because we could take the reciprocal of both sides. And when we take the reciprocal of both sides, the reciprocal of cotangent of x is tangent of x. And the reciprocal of 0 is undefined. So what we're looking for is values of x, okay, where the tangent is undefined. Well, tangent is undefined when cosine of x equals 0. Right? This is what we were talking about with the graphs. Right? This is where your asymptotes are. Tangent is sine over cosine. So when cosine is 0, it's undefined. And where does cosine equal to 0? Okay, well, think back to your unit circle. Let's see if we can find it. Cosine is equal to 0 when x is equal to 0. Well, x is equal to 0 here, okay, and here. If we take this value and we add pi, we get this value. If we add pi again, we get this value. Add pi again, we get this value. So if we find where cosine is equal to here, then we could just add pi times n. So what angle is this? This angle is pi over 2. And then we just add pi times n to get all of the answers. Now you would have lost this answer if you divided both sides by cotangent, okay? If you divided both sides by cotangent over here, you would have gotten rid of the cotangent and this answer would have been lost, okay? So this is the solution to one equation. Now we have to find the solution to the other equation. So our other equation is cosine squared x minus 2 equals 0. Okay. We add 2 to both sides. We get cosine of x is equal to 2. We take the square root of both sides. And you take plus or minus. So we get cosine of x okay, and you're probably sitting there thinking, but that's not in the exact value chart. You're right, it's not. In fact, this is impossible. There is no solution. How do we know there's no solution? It's outside the range of cosine, okay? There is no x value that you could plug in that'll give you plus or minus square root of 2. That's because square root of 2 is greater than 1. And cosine is the number that's less than 1, okay? So there is no answer. Cosine of x must be less than 1. Square root of 2 is greater than 1. Okay, and the same thing would be true if it's negative, right? Cosine of x has to be greater than -1, and negative square root of 2 is is less than -1. Okay, so this is outside the range of cosine. So you should pay attention to that. If you don't see it in your exact value chart and you plug it into the calculator and you do cosine inverse and it's outside, it gives you an error, that's because it's outside the range. Okay, so you should always make sure that your cosines are between -1 and 1, and if they're not, then there is no solution. Okay, so if you had done this, it would have looked like there was no solution to this equation, but there is a solution, pi over 2 plus pi n. Okay, so a little tricky there. Okay, let's do another example. This one we'll do with an interval. Let's do 2 sine squared x minus sine of x. And actually, I'm going to use theta for this one. You'll see why in a second. Minus 1 equals 0. Okay, so we look at this and we say, how do we do this? Well, it kind of looks like quadratic, right? So we solve it exactly like a quadratic. Okay, now some of you are, if this were quadratic, right, the first thing that we would do is factor. Now some of you may look at this and have a hard time factoring it. So my suggestion is to do a substitution. Okay, so this looks quadratic, so we treat it like a quadratic and we factor. And I'm going to add this in a second, but I want it in the interval from 0 to 2 pi. Okay, so I'm going to add in here. Zero to 2 pi. Okay. So how do we do this? So we can do a substitution. That might be helpful to us. You don't have to, okay? If you can factor it without that, that's fine. But some of you may not recognize it right away. So what you do is you say, okay, let's let x equal the sine of theta. So you always choose this middle term, okay? Whatever the trig function is. And if we do that, then what we get is 2x squared minus x minus 1 equals 0. And you solve that equation, okay? And this factors, I'm not going to go through the factoring with you because at this point you should be able to factor. Whatever method you use is fine, okay? This factors to 2x plus 1, x minus 1, and again, you can use quadratic formula as well. You can use completing the square, although I think that would be a pain in this particular problem. Okay, so you get 2x plus 1 and x minus 1. And then substitute back, okay? This is a theta. I wrote 0, but it's theta. So you can start by substituting. Then factor. Then substitute back. You don't have to do it this way. It's just if you have a hard time seeing it. So in other words, what it would look like. I'm not going to change the color, even though I prefer it or different. What it would look like is 2 sine theta plus 1 times sine theta minus 1 equals 0. So you can go straight from here to here if you want, okay? You don't have to do the substitution. The substitution is just there if it makes it easier for you to factor when you don't have the sine theta there. Okay, some of you will be able to do it, some of you won't. It doesn't matter what you do. Okay, then you're using the 0 property. So then you have two equations that you're solving. You're solving 2 sine theta plus 1 equals 0. And then you have sine theta minus 1 equals 0. Okay, and we solve. So in this one, we subtract 1 from both sides. In this one, we're going to be adding 1 to both sides. So on this side, we get 2 sine theta equals negative 1. On this side, we get sine of theta is equal to 1. Over here, we have to do an extra step and say divide both sides by 2. So our final answer here is sine of theta equals negative 1/2. So now we just have to solve each of these separately. So let's take this one first. We have to think about what quadrants we're in. So the quadrants, sine is negative. So we're in quadrants 3 and 4. So this is where sine is negative. That's how we know which quadrants we're in. Okay. And what's our reference angle? Well, what angle has a sine of 1/2? 30 degrees. So our reference angle is pi over 6. Okay. So you can think about it as pi over 6. You could think about it as 30 degrees and then convert to radians. That's up to you. In quadrant 3, so notice we're writing theta equals. We're not writing x equals. That's because our original problem uses theta. Now, especially if you did the substitution, x would be incorrect. There is no x in this equation, okay? So theta equals pi plus pi over 6 in quadrant 3. So pi is 6 pi over 6. So this is 7 pi over 6. So notice we do not write plus 2 pi n. That's because we have an interval here that says don't go past 2 pi. Okay? In quadrant 4, it's 2 pi minus pi over 6. So 2 pi here with a denominator of 6 is 12 pi over 6. So here we get 11 pi over 6. Sorry, put my 11 in the wrong place. Okay, sine of theta equals 1. Well, this is on the unit circle where the sine equals 1. This is where our y value equals 1, and there's only one place. There is no reference angle here, okay? It's on the axis. So on the axis, our theta is equal to pi over 2. So we have, if we just summarize here, we have theta equals pi over 2. We have theta equals 7 pi over 6. And we have theta equals 11 pi over 6. These are our answers to this problem. Okay, so we have 3 solutions. Sometimes you have 4 solutions. Let's take another one. Let's do a multiple angle equation. A multiple angle equation is a little bit different. Just in the very last step, okay? And we'll do this without an interval. So 2 cosine 3 theta minus 1 is equal to 0. So notice the difference here. It's not cosine theta. It's cosine 3 theta, okay? Now everything is the same until the very end, okay? So the very end is what changes. It only changes the very last step. Everything else we do exactly in the same way. Okay, so don't get rid of that 3. You leave that 3 until the very end. So we do the same thing that we would usually do. We isolate the trig function. So we're going to add 1 to both sides. That gives us 2 cosine 3 theta. Is equal to 1. Divide both sides by 2. That gives us cosine of 3 theta equals 1/2. Still, don't do anything about the 3 theta, okay? Think about what quadrants. Think of the 3 theta as like together, okay? It's grouped. So we're going to think about what quadrants we're in. The cosine is positive. Cosine is positive in quadrants 1 and in quadrant 4. These are the 2 things that we're looking at, okay? So that's how we come up with these. What's our reference angle? Well, the cosine, we're looking for where the cosine is equal to 1/2. So the cosine is equal to 1/2. The reference angle is pi over 3. So here's the difference, okay? We're not saying that theta is equal to, we're saying 3 theta is equal to. So in quadrant 1, 3 theta is just equal to pi over 3. And there's no interval, so we do 2 pi n. Okay? In quadrant 4, 3 theta is 2 pi. 2 pi minus pi over 3. Or 3 theta, 2 pi with a denominator of 3 is 6 pi. So it's 5 pi over 3. And then same thing, plus 2 pi n. Now we're not quite done yet, okay? We solve for 3 theta. And then, to find theta, we just divide everything by 3. I'll fix that in a second. So we have 2 solutions, right? We have 3 theta is equal to pi over 3 plus 2 pi n. So dividing everything by 3 is the same thing by multiplying everything by 1/3. That might be an easier way of looking at it in terms of the simplification. Okay, you also have 3 theta is equal to 5 pi over 3 plus 2 pi n. So our last step is to cancel out the 3. So our last step is going to be multiplying everything by 1/3 to get rid of that 3. So it gets distributed to everything. It's the same thing as dividing by 3. It just might make the division by 3 for the 5 pi over 3 and pi over 3 a little bit clearer. Okay, so what's our final answer? Theta is equal to pi over 9. We're almost there. Plus 2 pi n over 3. Here, theta is equal to 5 pi over 9 plus 2 pi n over 3. So that's the extra step, that if you have a number before this theta, your extra step is just at the very end to get rid of that number. So here at the very end, we get rid of the number just by dividing everything by 3. We'll do 2 more, okay? 2 more, and then we'll finish up. So 8, let's do 2 sine of 2 theta minus square root of 3 is equal to 0. Okay, so we're going to solve this like any other equation. We isolate the trig function by adding square root of 3 to both sides. This might be a good time for you to pause and try it yourself. Okay. So we have 2 sine 2 theta is equal to square root of 3. Divide both sides by 2. So now we have sine of 2 theta is equal to square root of 3. Remember, it is equal to square root of 3 over 2. Remember, this 2 theta is not a square. Okay, 2 theta is not a square. So now we identify the quadrants. So we are in sine is positive. When sine is positive, we're looking at quadrant 1 and quadrant 2. And we have to find our reference angle. And our reference angle is pi over 6, is pi over 3. That's the sign where square root of 3 over 2. Okay. Quadrant 1. So it's not theta, it's 2 theta is equal to pi over 3 and then plus 2 pi n. Same thing here. It's not theta, it's 2 theta. So in quadrant 2, it's pi minus pi over 3. So pi minus pi over 3, that's 3 pi over 3 minus pi over 3 is 2 pi over 3. And then don't forget to add the 2 pi n. Okay, so how do we solve? We multiply, we get rid of the 2 by multiplying everything by 1/2. Okay, or dividing everything by 2. It's the same thing. Because we're not trying to find 2 theta, we're trying to find theta. So we distribute to everything. Okay, the multiplying by 1/2, again, I just do it that way so that it might be a little bit easier for you to look at your denominator here. Okay, so we get rid of the 2. We get pi over 6 plus 2 pi n over 2. This means theta is equal to pi over 6 plus pi n. This is 1. Remember, you want to reduce your fractions, so the 2's cancel here. Okay. Here, we get theta is equal to 2 pi. I wrote 2 equals. Don't know where that came from. Theta is equal to 2 pi over 6 plus 2 pi n over 2. So what do we get here? 2 pi over 6 becomes pi over 3. And then once again, plus pi n. So 2 solutions. Okay. So let's think about what we did. Okay. Once again, we isolate our trig function. We found the quadrants. Again, based on whether our trig function was positive or negative. We found the reference angle. Using that, we were able to solve for theta. So depending on the quadrant, you're either doing pi minus theta. Sorry, you're doing, I got confused. You're doing pi minus theta, pi plus theta, or 2 pi minus theta, and then, or just theta itself. That depends on the quadrant. That's what we talked about at the beginning. And then finally, you're, in this case, dividing everything by 2, or multiplying by 1/2. Same thing. That's for this case. For the last case, we multiplied everything by 1/3. Okay. One last one. Two tangent x over 2 minus 2 is equal to 0. Okay. So same thing. We're going to add 2 to both sides. So we get 2 tangent x over 2 is equal to 2. Divide everything by 2. Again, all you're doing is isolating the trig function. So this cancels, and we're left with tangent of x over 2 is equal to 1. Now you're going to feel obligated to get rid of this 2 now. You do not get rid of it now. As soon as you isolate your trig function, you solve, okay? So quadrants, tangent is positive. So where's tangent positive? We're in quadrant 1, and we are in quadrant 3. This is where tangent is positive. What is our reference angle? Well, our tangent is 1. It's the tangent of pi over 4. Okay? The sine and the cosine have to be the same if the tangent is 1. That's only true for 45 degrees for pi over 4. Okay, so in quadrant 1, x over 2 is just pi over 4, and then we add the 2 pi n because we did not give you an interval. In quadrant 3, our x is pi plus pi over 4. So notice I just do this first, and then once I add this, then I add in the 2 pi n. You don't have to do it that way. You can add the 2 pi n at the very beginning, okay? I do it that way just so that I am doing the addition first, and then I can just add in the 2 pi over n at the end, and I don't have to worry about it in the middle. But some of you may forget to do that, so that's why I would be a little bit nervous. But that's all personal preference. But your final answer has to have the 2 pi n in it. Okay. So here we have 4 pi over 4 plus pi over 4. We get 5 pi over 4 plus 2 pi n. Okay. How do we get rid of this? How do we solve for x? Well, in this case, it's different. In this case, we're multiplying both sides by 2. And you're distributing to everything. So now we have our 2 answers. We have x equals 2 pi over 4 plus 4 pi n. Make sure that you reduce your fractions. This is your first solution. And if you have an interval, then obviously you just wouldn't have this 2 pi n, and your answer would just be pi over 2. Okay. Here we get 10 pi. And I'm going to rewrite this down here too, because it's really this one that you're multiplying by 2. It's not this one. So here it's x equals 10 pi over 4 plus 4 pi n. And we reduce, so 5 pi over 2 plus 2 pi n. And if you go straight to the 5 pi over 2 plus 2 pi n, that's fine. Do not skip this step, okay? Don't go straight from, don't go straight to this, where you go straight from reference angle to this. Don't do that, because I'm not going to know where your answer came from. So again, this is all about communication. This is all about repetition. It's all about verifying answers. We can't verify your answer if we have no idea how you got to your answer. So you do need this intermediary step, okay? You have to have that, where you say x over 2 equals, okay? And this is it. So these are all of the different types of equations that you would be asked to solve. So you should become familiar with them. And that's it for trigonometry. That's it for the whole semester. Okay, so we are officially done. And if you have questions, email me. It's probably going to take me a second to stop the tape, so stop listening and looking now.